Math 8. Today we are continuing our linear relationship. So a little bit of recap from last lessons. We learned about how we can input x value, which is known as independent variable, and how that x value can affect output value, which is y value, and that is known as responding variable. So far, every single example that we have been dealing with was about substitution, predict, and then finding out the pattern. Last class, we talked about how patterns can be identified in table and how that values have a certain amount of increase or decrease on x-axis, which is horizontal. We call it run, and increase or decrease in y-axis, which is known as rise. Even though I'm not a big fan of the word using rise over run, because in English word rise mean increasing all the time, but in real math situation, y value can decrease. There is a possibility that the slope can decrease too. So today's lesson actually involves linear relationship in terms of word problem. We're going to do about 3 to 4. The page that we're located at is 19 of your math dioteng or booklet, if you will. So let's look at some of the example. Sound travels 1,500 meters per second in salt water. This relationship can be expressed by the formula d is equal to 1,500 t, where d is a distance traveled in meters and t is time in second. Using that word problem or scenario, we need to make a table of values using integers only, graph the ordered pairs in the table of value, and see is it reasonable to have points between the ones on the graph, and D, calculate the distance sound travel in 3.5 seconds. So we're not talking about slope in here yet, but eventually we're going to figure out. So obviously, the most important clue is this linear relationship that is provided by the question. D is equal to 1,500 t. First thing first, I'm going to copy this. And it is our job to figure out which one behave as y, which one behave as x. So, basically, it's a fancy way of referring. Does time affect the distance? Or does the distance affect the time? We need to find that relationship. Distance doesn't affect the time actually. Time affects the distance. What I mean by that is this. If you look at the first sentences, it says sound travel 1,500 meters per second. That's a fancy way of referring that. It can be per 1 second, per 2 seconds, per 3 seconds, and so on. So, per second means, or anything that go per something. From now on, you can think that as independent variable or input value that affect the output, which is defined as x. So, x is actually work as time, y is actually work as distance, meter and second. So, here's what we do. I want you to create a table of value. X first, or y. Yeah, x, generally you can put it on the left. People do that most of the time. Unit. And D, y-axis, distance, I believe it was meter. That's what you do. Now, in order to substitute some of the values, it is good idea to have some values, 0, 1, Oops, I omitted 2. There you go, why not? It doesn't matter how many, but it's a good idea to have more than 3. In my case, I put 0 all the way to 5. And each of them, we're going to substitute to figure out the values. One thing that you need to understand is we are going through this one by one. And eventually, once we find a pattern, which is again about 2-3 substitution, then we are going to find a pattern between each of the second and each of the distance. So that's a process called finding out the slope, by the way. Time is 0. Then d is equal to 1,500 t is a fancy way of saying 1,500 times value of the t, which is 0. So that means we have 0 meter. When it comes to 1, 1,500 times 1, which is 1,500. Second one, so that's when d was 1, d is 2 now. 1,500 times t, which is 2, then it's 3,000. And generally, like I mentioned, I substitute about 2 or 3 data, and then I go through some of the pattern. T part is easy because, well, we created a pattern. Every time we increase things by 1. But when you look at the pattern of distance over here, you may notice from 0 to 1,500, it added by 1,500. Does that pattern happen for the second set, which is data 1 and 2? Yes, we do. 1,500. Then what will be my next one? Well, 3,000 plus whatever that pattern, right? 4,500. The next sequence, 6,000. The next sequence, 7,500. And it's going to go on and on. So part A is done. We use integer and we make a table. B, graph the ordered pair. Now, if I create a graph, in this case, we are focusing on the quadrant 1, so it's a good idea to just focus on the quadrant 1. It is good idea to put each of the variable time as a second, because that's like x, and for the y, remember, orientation, you're going to change distance, and that's meter. The only thing that you got to be careful is time is easy. There's 0, 1, 2, 3, 4, something like that. But when it comes to, I'm just going to put that over here. And when it comes to y-axis, it's a good idea to indicate that each of them goes 1,000 level. So 1,000, 2,000, 3,000, 4,000, something like that. 2,000 I didn't put. You can actually put over here, even though technically it's a good idea to put it on the left side, but because of the time and space problem. 0, 0, that was a 1 coordinate. 1 and 1,500, which is halfway over there. 2 and 3,000. 3 and 4,500, which is slightly above. And you have this pattern. As you may notice, this pattern is linear, so use your ruler. And I want you to extend the line. So we graph the ordered pair. So second part, check. Is it reasonable to have a points between the one on the graph? So in this question, it is asking, is that possible to have any coordinate in between? I like to say, when it comes to C, yes, it is possible because the linear relationship shows a continuous pattern. So any type of coordinate can actually place in this line. Having the line means it's continuous, ladies and gentlemen. The only problem is then it should be like in decimal. And that actually connected through my question D over here. D is asking, calculate the distance when the sound travels 3.5 seconds. So that is a fancy way of saying D is equal to, and 1,500, you know that was original number over here, multiply by time is 3.5, so you are multiplying 3.5 and the unit will be meter because the distance unit is meter. So I want you to take out your calculator. Right now I'm gonna use the one on a computer monitor, but you guys have it. So using your calculator, I want you to put 1,500 multiplied by 3.5. Then the number that I have from my screen is 5,250 meter. And that is possible if we have a continuous graph going on. It will be located somewhere around here. So I like to say, locating this distance, it is reasonable to have a points between one and to another, because that's just saying that any of random points that you can have from like, I don't know, 2.5 seconds, something like that, you can locate over here and predict that. So that's why. This is how you're dealing with the word problem. Let's do the other example. Instead of 4 example, I think with the time limit, we may do 2, and then you guys can give it a shot for the others. That means, why don't I go through, there you go, an example on page 21. Gonna read the question. Use the linear equation y is equal to negative 3x plus 4 to complete the following step. A. Make a table of value. Use positive and negative integer and 0, giving you a lot of condition, and graph the order pair in your table of value, and I want you to locate 11 and y. So in this case, the word problem is quite more direct, if you will, because we know y and x directly. If it's the previous situation, we gotta find out what's a time is our independent, or what's my responding variable is my distance. We already know that independent variable, which is shortly known as input, as x. Responding variable, which is known as output. We can use these guys. Since we know x and y, and we don't have any unit, we can create our table of value like that. The only thing that I gotta be careful is, as you may notice, negative integer 0 and positive. We gotta find both situations. So it doesn't matter what number that you choose, but probably I'm gonna go negative 2, negative 1, 0, 1, 2, something like that. And then next step is I am going to substitute. So for example, what will be my y value if I substitute negative 2 instead of x? Well, first of all, negative 3x, fancy way of saying negative 3 times whatever the x value, by 4. Something like that. The next one, negative 3 times whatever the value that you see. Same sequence. Exact same sequence. There you go. You can use your calculator too. Negative 3 times negative 2 give you positive 6. So it's a 6 plus 4. That give you 10. Negative 3 times negative 1. Negative times negative always give you positive if you like to do mental math. 3 times 1 is 3, so there you go. Negative 3 times 0 give you nothing, so 0. 0 plus 4, which is equivalent as 4. And to be fair, like I mentioned, if you look at the relationship between x column and y column, we know that x, and again x, we can create it. It increases everything by 1, but when it comes to y, I want you to look at what's happening. 10 to 7. That means we subtract 3 to get there. Does that pattern repeat? Yes, we do. 7 to 4, decrease by 3. So you can actually predict what's going to happen. 4 minus 3 is equal to positive 1. 1 minus 3 is equal to negative 2. Double check using our substitution. 3 times 1 is 3, but negative and positive, if you multiply different sign, that become negative. Then add by 4, give you 1. Negative 3 times 2 give you negative 6, plus 4 give you negative 2. So as you may notice, these guys are all matching. So 10, 7, 4, 1, 2, negative 2. They are all matching. So we just created a table A. A part is done. B. Graph the order pair in the table of value. This time, we have a concept of positive and negative. So it's a good idea to have all of the quadrant 1, 2, 3, and 4. You don't have to put this Roman numeral, but this sometimes help you because negative 2 and 10 give you some idea which coordinate belong to where. Negative 2 and 10, the first one goes there. Negative 1 and 7, get it over here. 0 and 4. Then next one, 1 and 1. Next one, 2 and negative 2. Then we can connect these lines. I know my graph has been a little ugly, but long story short, increasing and decreasing, it is very evident, as you may notice. It is decreasing slope. We call it negative slope. And I'm going to explain to you why slope is negative. Because if you look at points by points, can you see that from the first to second, you are moving it right? By 1, to be honest. That's what you identify over here, plus 1. But look at the vertical pattern. Does it increase? No, it's not. It actually dropped by 3. Drop, drop, drop. So as you may notice, this graph is a one that goes right by 1, go down by 3. And that one is evident over here. Whenever you see this kind of pattern over here, ladies and gentlemen, we call it's a negative slope because the graph drops, basically. Although the question doesn't ask you that much, but this is an example that we're going to go through when it comes to the next class, so have that in your mind. C. Determine the value of y in the order of 11, y. So we need to find out what's y when we know the value of x if it's 11. There are different ways that you can do. One way is you can continue this graph all the way down and then go to 11 and then find out that row, which is quite tedious. The best way that you can do is a substitution. So I want you to copy your linear equation first, or expression, sorry. And we're trying to find the y value once we substitute x that is equal to 11. So instead of negative 3x, it's negative 3 multiplied by 11 that is equal to 4. And do everything. You can use calculator at this point too. 3 times 11 is 33, right? Let's look at the sign. Negative number multiplied by positive number give you negative number. That's the lesson that we did in the multiplication of integer, right? And plus 4. then what's the value that you have? Well, negative 33 plus 4 give you negative 29. So that means using these values, we can actually create the coordinate that the question is asking. If x position is 11, then the next one should be negative 29, which is possible because can you see that every sequence is going right by 1 and then 3 by down? So this 11 and 29 will be somewhere located way over here if this line was continuously going. We call this a prediction step. By substituting some of the value, we can actually predict what's going to be the outcome. That is today's lesson, ladies and gentlemen. The assignment or homework questions will be assigned to you right after this.